All right, guys, last section of notes for this unit. I know, you should be so excited. All right, last section is about dilations. Now, this word should sound very familiar to you because it's from Unit 2 whenever we did transformations. If you recall, we had 4 different transformations. Dilations was one of them. We didn't focus on it back in Unit 2 because dilations is not in isometry. Instead, a dilation is a transformation that changes the size of a figure, but not its shape. And we're going to look once again at pre-images and images of figures that are going to be similar. That's why dilations are in the similarity unit. All right, scale factor is the similarity ratio of a pre-image to an image that describes how much the figure is either enlarged or reduced. So whenever we're talking scale factor, like if we've got a scale factor of 2, that means you double the size. If you've got a scale factor of 1/2, that would mean you are cutting it the size in half. So your scale factor is going to be written, remember our transformation rules. So we'll have a rule where it's x comma y transforms to your k value is your scale factor. So that could be a 2, that could be a 1/2, that could be a 1/4, 3/7. It could be really whatever we put in here. And then if the k value, if your scale factor is greater than 1, it's an enlargement. And if your scale factor is between 0 and 1, then your dilation is a reduction. The center of dilation. So the center of dilation is a fixed point where all points from the preimage to the image are either enlarged or reduced. So a line connects the points from the center to the preimage to the image. So as you can see in this picture right here, C is your center, and then P is your preimage, and then P prime, remember we put the little apostrophe there for prime, that would be your image. So if you were to have this, whenever we look at it here in a minute, you have got to have a straight line that can be made through all 3 points, and that is a correct dilation. All right, let's just practice scale factors to start. So state whether each of the following scale factors are enlargements or reductions. So the first scale factor, SF, means scale factor, is 2. So 2 is greater than 1, so that would mean this is an enlargement. Scale factor of 1/3, that would be a reduction. Scale factor of 0.6 is less than 1, so that would be a reduction. And then a scale factor of 6/5. So 6/5 is actually greater than 1 because the numerator, if you were to write it out like this, 6/5, so this would actually be an improper 5 goes into 6 one time, and then there would be 1 left over out of 5 pieces. So that is greater than 1. So that would be an enlargement. So just because it's a fraction does not mean that it's going to always be a reduction. You need to pay attention. All right. The dilation with the rule x comma y transforms to scale factor at 2/3 times your x and y. We're going to do that center dilation with the center being at 0, 0. And we're going to apply that to the polygon ABCD. What are the coordinates of the image? So if we look at A, this is your x, this is your y. So to get A prime, what we would do is we would take 2/3 times your x and then 2/3 times your y. So 2/3 times -9. I like to reduce and then enlarge. So you can, if you want to do it all at once, type into your calculator 2 divided by 3, parentheses, -9. You could also type in 2 divided by 3 times -9, or you could do it in your head. So I can take -9. I want to lower the number first. So I'm going to divide -9 by 3 because that's on the denominator. So that would give me a -3. And I'm going to multiply -3 by 2, which would give me a -6. So my a prime x value is -6. And then 0 times anything is just 0. So there's that. All right, b prime, you're going to do the same thing, except for you're multiplying 2/3 times 3 and 2/3 times 9. So 2/3 times 3, plug it in. That would give you, you could do 2 times 3, which would be 6, divided by 3, which is 2. And then do exactly what we just did with the 9. 9 divided by 3 times 2 would give us 6. C prime, we have another 9, so that's going to be 6 again, another 0. And then D prime. -3 divided by 3 is -1, times 2 would be a -2. And then -9, we already found that answer at the beginning to be -6. Once again, if you can't do all of that in your head, either follow the formula from the beginning right here with A prime, or plug it into your calculator. All right, find the scale factor for the dilation that maps the solid line figure onto the dashed line figure. So we are going from solid to the dashed. So make sure you start here on the solid line. So how we're going to do this is, first off, we're going to pay attention to the fact that solid to dotted or dash, we got smaller. So it's going to be a reduction. So our scale factor has got to be less than 1. And then I'm going to pay attention to like my points. So I got a point here at 4, and then a point here at 2, and then I've got to go from 4 to 2. So that would be cut in half, 4 divided by 2. So then I'm going to pay attention from here to here. And it's all about slope, really. So it looks like 4, 4. And then from here to here would be 2, 2. So once again, this is 4, and then this is 2, and this is 2. So we cut those lines in half. And then lastly, it looks like the same thing over here. So that's a 4, 4 slope. And then from one dot to the next would be a 2, 2 slope. So it looks like we cut all of them. We went from 4 to 2. So that would be a reduction of cutting it in half. So find the scale factor of the dilation. So we write scale factor equals 1/2. Simple as that. All right, flip the page. Dilations with the origin at the center. So we're going to start with an easy dilation here. It says draw and label the image of triangle PIG that has vertices of the following under the dilation of the scale factor of 3 centered at the origin. So what you need to highlight and know that is important is your scale factor is 3. So our rule then would be x comma y transforms to 3x, 3y. And then we also need to pay attention to the fact that we are going about the origin. So we're going to go based straight on slope with the origin here. It makes it very simple. So we want to enlarge this triangle by 3. So here's what we're going to do. I'm going to start with P because it was triangle pig. So I'm going to start with P here. So P is 3 away from the origin. So 3 units away from the origin. So what we're going to do is we're going to multiply that by 3. So we're 3 units away here, And multiply that by 3. So that means P prime needs to be 9 units away from the origin. So here's P prime. Got it? All right, now we're going to look at I. So starting at the origin, do your slope. Rise 1, 2, go left 1. So we went up 2, left 1. And we have to do a scale factor of 3. So times it by 3. So I'm going to go up 6, times it by 3. I'm going to go left 3. All right, up 6, left 3. So up 6, 1, 2, 3, 4, 5, 6, and left 1, 2, 3. So right here is going to be I prime. Good with that? And then lastly, G prime was on the y-axis, down 2. So if we go down 2, times that by 3, and we need to go down 6 to get G prime. So G prime should be down 6. And then we connect them. And then we need to pay attention because the instructions said draw and label the image, and we need to write the vertices. So P prime is at 9, 0. I prime is at 6, negative 3. And G prime, that was an ugly G, is at 0, negative 9. No, negative 6. All right. So there's the first one. Let's do it again. Draw and label the image. Oh, I gotta sneeze. Hold on. Oh, allergies. All right. Draw and label the image of the parallelogram PQRS that has these vertices under the dilation with a scale factor of 1/2. And once again, we're centered around the origin. So this time, our rule is we're going to cut all of our values, our slopes, in half this time. So let's check that out. Up from to R, we went up 2. So we need to cut that in half. So that means this time I need to divide by 2 instead of multiply by 2. So that's going to be up 1. So here is R prime. I'm going to go to Q. Q is at 2 units away from the origin. So I'm going to cut that in half. So I'm going to go 1 unit away from the origin. So Q prime. All right, P is 4 units away over here. We need to cut that in half. So P is going to be, P prime is going to be 2 units away. And then S looks like it's at 6, 2. So we need to cut that in half. So then that would be at 3, 1 for S prime. Make sure you draw it. And we are gravitating towards the origin like we should be, and our dilation is half of the original free image. So let's write our vertices down. P prime is now at 2, 0. Down this time. Q prime is now at 1, 0. R prime is at 0, 1. And S prime is at 3, 1. Simple enough. All right, let's flip the page, last page. Now we're looking at non-origin centers. So first one here, transform circle C, so here's circle C, by a scale factor of 2, so let's highlight that, scale factor of 2, with a center of dilation at 3, -2. So our center is no longer at the origin. It says graph the pre-image and the image below. So we don't have an original figure, so we need to draw circle C to start. So circle C looks like its center is at 0, 0. So we're going to draw 0, 0, its center, and then its radius is 1. So I'm going to go 1 unit away for that circle. So here is circle C. Now we need to draw circle C prime. So the center of dilation, we're not doing the origin, is going to be at 3, -2. So I'm going to go put that center, put the point of origin, 3, -2. Right here, I'm going to call that P, point of origin. Okay. Now, how in the world do I do a circle? It's very simple. I'm going to get a different color to help you out. It's actually a lot easier than doing other figures because you only have one slope to find. That slope is going to be starting at your point, your center of dilation. You start there, and then you're going to go 1, 2, 1, 2, 3. You're going to go to your center of your pre-image. So we went up 2, left 3. Now it said our scale factor was 2. So that means we need to double this. So instead of going, let's get a different color. Instead of going up 2, we're going to go up 4. So 1, 2, 3, 4. And instead of going left 3, we're going to go left 6. So 1, 2, 3, 4, 5, 6. So here is C prime, my new center. Now, if you remember our talk about center of dilations, is that you should be able to draw a straight line from the center of dilation through your pre-image to your image, which I can. I can draw a straight line through all 3 of those points. That means I've done this almost successfully. The next thing is we have to draw the circle. So I know where, sorry, this is 4, -6. So I know where the center of my circle is, but now I need a radius. So my radius for my pre-image, circle C here, was 1. Scale factor is 2, so that means I double my radius. So I'm going to have a new radius of 2. So that radius would be here, 2 units away everywhere you go. See that? 2, 2, 2. So 2 units every side of the circle. And that's it. Circles are super simple. Now we just have to give our answers. So the center of image C prime, so the middle of C prime is at -3, 2, and then our new radius is 2. All right, hopefully that made sense to you. If not, pause, rewind, listen again. Okay, let's move on to the last one here. Apply the dilation to the polygon with the given vertices of the pre-image. So it looks like we have our rule written here. So that means our scale factor is 1/2. So we're going to cut this triangle in half. In the center of dilation is -5, -8. So let's go see if we can do that. First thing, put your center of dilation down. So -5, -8 is right here. So this is our P. This is our point or center of dilation. And then we want to cut in half. So we've got to do slopes again. 3 slopes this time because we are doing 3 triangle. So it's not a circle, it's not as easy. So 3 slopes. So I got to go from P all the way up to F. So it looks like we got to count. We went up 16 and we went right 2. Up 16, right 2. So we have got to cut that in half according to our scale factor. So that means I need to go up 8 and over 1. Now we start that from our point, our center. So up 8, right 1 is going to be here. So this is F prime. All right, let's go to, I'm going to go over to D. So we got to go back up 16 again, and then over to D, which is 5, 10. So we went right 10. So now we got to go up 8 and right 5. So it looks like that would be at the origin. D prime. And then lastly, we need to get to E. So we're going, how many is that? Up 10. And then right 7. So we need to cut that in half. So that means we would go up 5. 1, 2. And then 7 cut in half would be 3.5. So we went up 1, 2, 3, 4, 5. And then we need to go 3.5 to the right. So 1, 2, 3 and a half. So that's going to be like in between the 2 lines. So there's E prime. And then connect the dots to give us our dilation. Now, I will tell you that if you don't start at your center of dilation whenever you start counting slope, if you don't start at your center of dilation with your slope, you're going to mess up your entire problem. So if you start counting like from your point here and you go over and down or something, your triangle is going to end up like up here, which will be 100% wrong. So please, please, please make sure that you start counting your slope from your center of dilation. I always typically label it point P for some reason, point of dilation, I don't know. But that's where I start. That's where you should start to make sure your image comes out correctly. All right, we need answers over here, or order pairs, sorry. So state the coordinates. D prime is at 0, 0. E prime, we left 1.5, so negative 1.5, perfectly legal. And then negative 3 for the y value. And then F is at negative 4, 0. All good? And just to verify, remember you can always check to see if you did your dilation right. If you draw that straight line, starting at your center of dilation through your image and pre-image points, you should be able to draw a straight line through all 3 points if you have done this correctly, which you can see is true for this figure. Looks kind of cool, like a 3D model, like like coming out at you if you draw the lines. The lines are not required. They can just prove to you that you have done the dilation accurately. All right. Now we have a couple questions to answer. Part B, identify and describe the above transformation. First off, it was a reduction because we cut it in half. So identify, it's a reduction, and describe it. So describing it would be by saying that a reduction by a scale factor of 1/2. So you've identified it by saying it was a reduction, and then you've described it by telling me what the scale factor is. 2 parts. You have to have both to get full credit for part B. Ooh, all right, part C. Show algebraically that ED is parallel to E prime D prime. So how do we figure out 2 segments are parallel? Hopefully in your head, back from your algebra skills, you're saying parallel means slope, same slope. We've done that in, I think it was quadrilateral unit 4 maybe. So we need to figure out if these 2 segments have the same slope. That will prove that we've got parallel segments. So ED, its slope, it looks like, is 2/1. And then E prime D prime looks like it's 2/1 as well. So show algebraically. So what I'm going to do is write ED, the slope of it is 2. If you'd like to put 2/1, you can. And then E prime D prime, its slope is also 2/1. So that's it. That's all you got to do to prove that they're parallel. That's all that we have for dilations. It's essentially doing slope over and over and over and over again. Get used to it. If you have any questions, email please and ask for help. Rewatch the video if you need to and get started on your worksheet. All right, bye guys.